In this video, I want to have a look at finding the volume of pyramids and cones in problems or in situations where we're going to have to use Pythagoras' theorem to help us solve them. So we know that the volume of a pyramid is going to be a third times the area of the base times the height. Now in that formula, the h for height must stand for the perpendicular height. So that's from the very apex, the top, straight down into the bottom of the pyramid. So we want that vertical height, that perpendicular height. We don't want this slant height that's leaning up against the edge of the shape. So if that is what we're given, if we're given the slant height, we're going to have to use Pythagoras' theorem to figure out what that perpendicular height is. So first off, I'm going to take out this triangle. So off to the side here, I'm going to redraw that right-angled triangle that's in our shape. So we've got our right angle here. This is our perpendicular height, our h. We know that our slant height is 26. And we need to know what this base length is. So that's the length of this side going along here. So we know that the base of this side is 20. So if we're going from one edge just into the middle instead of the whole way across, then the base of this triangle is going to be 10. So then we can use Pythagoras' theorem. So h squared is going to be equal to, now because h is one of the shorter sides and 26 is our hypotenuse, we're going to have 26 squared minus 10 squared, which would give us 576. And then to find h, we're going to take the square root of that. So h is equal to the square root of 576, which is 24. So now that we know that perpendicular height, we can use our volume formula. So our volume is going to be a third times the area of the base. Now this is a square pyramid because it's 20 by 20. So we can just write 20 squared, or you can write 20 by 20. And then times that perpendicular height, which we just found was 24. And then we can put all of that in our calculators, and we're going to end up with 3,200 centimeters cubed for our volume. Let's have a look at one more example. Now our second example looks a little bit more complicated because it's a rectangular pyramid instead of a square pyramid. So we've got one side length of that base being 96 meters and the other side length being 30. So that means to find this perpendicular height, there's two different ways we could go about it. We could use this slant height of 52 and look at this triangle, or we could use this slant height of 25 and use this triangle instead. And it doesn't matter which one we use, we're going to end up with the same perpendicular height. So for now, I'm going to run through both of them just to show you that it doesn't matter. But when you're actually working them out, you only need to do one of these methods. So if we have a look at this one here first, so we'll draw our triangle out. We've got our right angle, our perpendicular height, and our slant height of 52. Now this whole side along here is 96, which means the base of our triangle is going to be half of that, and half of 96 is going to be 48. And then we can use Pythagoras' theorem. So we're going to have h squared equals 52 squared minus 48 squared, which would give us 400. And then if we take the square root of 400, that's going to find us h. So h would be 20. Now if we'd chosen to do the other triangle instead, we still would have h as our height. Our slant height here would be 25. Now this side length along here is 30, which means if we're going from the center out to this side, that's going to be half of that, which would be 15. So now we have h squared is equal to 25 squared minus 15 squared, which would again give us the 400, so that when we square root it, we do end up with 20. So again, you only need to do one of these, so one or the other, not both, but either way you're going to get that same perpendicular height. And then we can find our volume by going a third times the area of the base, which would be that 96 times 30 to find the area of that rectangle on the bottom, and then times our perpendicular height, which was 20. And if we multiply all of that together, we're going to end up with 19,200 meters cubed. So that's having a look at volume problems that need us to use Pythagoras' theorem.